All right, Tigers, how are you? Podcast Thursday, 326. Utility maximization. Something we need to have learned in and locked in. So, what we want to look at, I'm a page ahead here, is what is it like when you want to compare two things that have different prices? So, let's say you want to take a vacation and you want to maximize your utility. We talked about utility. Another word for utility is benefit. So based on the info below, which one of these should you choose? A trip to Tahiti or a trip to Chicago? Well, if just looking purely at benefit, we would pick the trip to Tahiti, right? Because it's more benefit than Chicago. The problem is that we're not taking into account cost, okay? So marginal utility, in other words, marginal benefit. Another word for price is marginal cost. So how do we decide which would be the best way to go? It's this term called utility maximization, which is taking the marginal benefit or marginal utility, putting it over top of the price. Okay, so when you do that, you get marginal utility per dollar spent. So if a flight to Tahiti costs $3,000, pretty expensive, right? You take 3,000 over 3,000, you get one. A trip to Chicago is easy. 1,000 over 500, okay, makes it two. So based on this thing, you always pick the higher of these numbers. The trip to actually take that will give you the most benefit, guys, is to go to Chicago, right? So where does that come into this point here, right? Okay, so you'll see I have the numbers filled out here. I made a mistake on the last podcast I was doing, so I just left the numbers in there. So we want to see if, should we go to the movies more or go to the go-karts more? Or what combination in between should we do, right? So here's the marginal utility going to movies. Here's marginal utility going to go-karts. So here's the column that we need to focus on, this MU over P. And here's the column we need to focus on, this MU over P, right? So we take the MU, which is 30, put it over top of the price, which is 10, and it gives us 3, and then 2, and then 1, and then 0.5. And you do this little math problem down, and you do this little math problem down over here. Price is 5, 10 over 5 is 2, 5 over 5 is 1, and so on and so forth, right? So we have $25 to spend. So the question is, what combination of movies and go-karts maximizes your utility, gives you the most benefit? Well, the highest number over here, guys, is that 3. Okay, so what I always like to do is I take my total amount of money that I have, which is 25, there's my 25, and I take away 10, so now I have 15. So now I look for the next highest numbers, and lo and behold, we have a tie. Going to the movies a second time and going to the go-karts a second time gets me there. This costs 10, this costs 5. Take away 10, take away 5, now I have $0 left over. It doesn't matter what order I do them in, and it doesn't really matter. But the point is, for me to get my benefit, excuse me, or to maximize my benefit of everything I'm doing, I need to go to the movies twice and the go-karts once. I spent all my money. 30 plus 20 plus 10 is 60. That's the highest combination of benefit I can get for the value at that point. So the way you answer this question is, I go to the movies twice and I go to go-karts once, and therefore I'm happiest. Because if I do any other combination, my marginal utility will be lower, and I don't want that. Okay, so let's do the same thing here in terms of apples and oranges. This equation is going to be very important for us in a moment because we want them to equal each other, and I'll show what I mean by that in a second here, right? So I've also filled out the chart over here at this point, and I apologize I have the answer right now, but let's go through and see. Okay, I've calculated all the marginal utilities for you, and there's the MU over P because the price of an apple is $1, okay? Oranges, there's the total utility. I figured out the marginal utility, and the price of an orange is $2. Okay, if you're having issues with how to calculate marginal utility or MU over P, you really got to send me an email so I can go through it with you at this point. So, well, the question is, if the consumer has $7, what's the combination of maximize utility? So we look here. Most highest number we have is this 20. Okay, that's $1. 7 minus 1 is 6. Next highest number, 15. And a 15. All you do is count the circles. Okay? 2 and 1 is 3. 6 minus 2 minus 1 is 3. Look at that. A 10 and a 10. Okay? Now I have $0 left. Okay? Not an issue going forward at that point. Okay? So how many apples do I buy? 1, 2, 3. How many oranges do I buy? 1, 2. Good to go. Right? So the last problem that we want to get to, guys, is this idea of putting those equations the same as they were before. So just like we looked right here, mu over p equals mu over p. So you guys see how it has an x and a y. Those are variables. So in this problem right here, we're doing peanuts and bananas. So Sasha is a utility maximized consumer, spends all of her income on peanuts and bananas. Ladies and gentlemen, Sasha has the worst colon known to man. Oh, God. Okay? So assume the last unit of peanuts consumed increases Sasha total utility from 40 to 48. Okay, which means the marginal utility between those two items is an 8. Okay? And that the last unit of bananas consumed increased her total utility from 52 to 56. Well, that's a 4. Okay? So the equation, guys, is that we need to figure out is how much does a banana cost? Well, we know that mu over p equals mu over p. So we have the marginal utility of peanuts, that's 8, over the price of peanuts, which is $1. So 8 over 1 equals 4 over x, right? Because we don't have the price of that at that point. So what we need to do is some basic cross multiplying. We get 8x equals 4, right? And then we have to get that 8 by itself. So what ultimately happens is, guys, is that by using cross multiplication, we figure out that x is worth 50 cents. Okay? And that's pretty cool. So now we know how that is. Okay? So the second question is, if the price of a unit of peanuts increases, okay? So here, this number is going to get bigger, right? And the price of a unit of bananas remains unchanged from the price you determined in part A, how will Sasha's purchase of peanuts change? It's a great question. Okay, so what's going to happen, guys, is that the price of a unit of peanuts goes up. So in reality right now, guys, we have 8 over 1 equals 4 over 0.5, which means it's 8 over, or 8 equals 8, right? Which means we're equal. All of a sudden, this number gets bigger. Let's say it's now $4 a banana, right? Okay, which means it's not 8 over 1, it's now 8 over 4, which now makes this 2 over 8. And these two are not equal. I would hope that you guys know that 2 and 8 are not equal at that point. Okay, I don't know what that means. Go away. So the question is now, how do you get these to be equal, or closer than they are right now? Well, what this comes back to, guys, is this idea of diminishing margin utility, right? Which is the more of something that you have, the less you value it, right? So the solution is, if you get an inequality here in terms of peanuts and bananas, whatever the case may be, take more of the higher number, because if you buy another banana, your benefit from that banana is going to go down. So this number will shrink, and you'll buy less of the smaller number. And if I buy less peanuts, that number will go up as well. So we're going to do a problem like that tomorrow to make sure we're clear about how that goes. Okay? Big set of lessons coming up here in terms of these things. You have to be able to do the diminishing margin utility rule of utility maximizing. Okay? A couple simple problems tomorrow. Log into office hours. Nobody was there today. Okay? I'm taking attendance and seeing who's there, and people aren't doing warm-ups. It's not a good thing. I love you and I care about you. Okay? We'll see you soon. Go Tigers.